Welcome to the HVAC-OLOGY experience, where we talk about all things HVAC industry, topics that are so hot, they are cool.
Okay, welcome to HVAC-OLOGY episode number 3. I am very excited today because we're going to be taking a subject matter of probably what every commercial industrial building has and be able to dive deeper into that to where a lot of folks get to have some knowledge. But I am your host, Ryan Hudson, and with me today is Mrs. Kelly Kapowski-Patterson. Hello, Kelly Kapowski-Patterson. How are you today?
It's a new name every time, Ryan.
Yeah,
I can be whatever though.
I just wanted to hear about your relationship with Zach Morris back in the day.
Zach and I go way back.
Did you watch Saved by the Bell?
I loved Saved by the Bell, but I was older though. Like I was an old person watching. It was kind of creepy for me to be watching Saved by the Bell.
Right? So you're a closet Saved by the Bell person, is what you're saying.
Right. Who's that geeky guy? He was so fun. Slater, Stryker, Slater.
No,
I remember his name.
No. AC Slaughter was the jock, and then you had.
See, you're the closet.
The geek guy.
The Bell fan.
Yeah, Screech.
Screech. Oh yeah, that's his name.
The geek guy.
I watched that religiously.
Yeah.
Did you have a crush on Zach?
That explains a lot,
No,
Natalie.
the other one.
The other one.
Slater,
the
wasn't that
dark-haired
his
one?
name?
Yeah, AC Slater. Is it Slaughter or Slater? Yeah, Slater.
I think it's
Slater.
It was, yeah.
Zach was blonde, right?
Yeah. No.
Yeah.
You're trying to play it off now, Natalie. Well, interesting thing. So I've been reading this book by Elon Musk, his biography, and I cannot put this thing down. And an interesting thing about this is when they were trying to build the SpaceX, they were trying to cool the inside of the first shuttle that they were going to launch. The price that they got quoted was $3 million to put in a cooling system. And so Elon tells his engineers to go and find I don't know what the tonnage was, but basically something off the shelf. And they took a package unit, standard electric package unit, and modified it to where it could cool the entire shuttle, and ended up costing him $6,000 to buy it. So it went from $3 million to $6,000.
Wow.
That's cost savings at its finest. So so Kelly, with us today we have Natalie Greene. Hello, Natalie.
Hi.
Hello, and Mr. Perry Conte.
How you doing today?
Doing well, thank you. So today we're going to be talking specifically about ABB drives, variable frequency drives, for those of you that don't know what VFD stands for, which is a common acronym that we use in our industry. So Natalie, could you tell us how in the world did you get from high school to where you're at today? 5,000-foot view.
Well, let's see. I'm gonna have to dig a little far back, but not that far, I guess. When I graduated high school, I actually had no idea what I wanted to do. I started in hospitality, switched to criminal justice, and then ended up in healthcare, actually. So I used to work at the bedside as a CNA. I did that for 2 years, and I was just like, okay, there has to be a better way to serve people, but not in this sense, if that makes sense. Like, it was great and all, don't get me wrong, but you have to have a passion for that. And I applaud people that do, but I was not one of them. And I actually had a friend at the time who worked here, and I saw she posted something on her Instagram story. And I was like, well, what does she do there? Like, that's HVAC, what does she have going on? So I went through and I stalked, and I went on the website, and I found a job application posting, whatever, and applied. And I ended up in our order and billing department, and I stayed there for a year. And then something came up with ABB drives. And to be transparent, I could tell you maybe a product code about a drive, but that's it. Because I would put them in on the blue sheets and enter them for billing, and then that would be the end of it. And I was like, okay, well, I'll just apply and we'll see how it goes. I knew that I wanted to grow within Hoffman, but I didn't really have any idea what that meant. So I fill out the application. I go to Adam, who was our branch manager at the time. Well, he still is, but we've switched back and forth. And he was like, okay, well, why do you think this would be a good fit for you? And I was like, well, it seems really specialized. And I like that because I'd rather take one thing and run with it than have 100 things that I need to be a champion of. And I interviewed with Perry, and that was comical. It was fun. And then he was like, you know what? If you can do it with me, I could do it with you. This will be a great time. And I ended up in ABB Drives, and I've been there with Perry for the last 4 years.
Wow.
And it'll probably take me 50 more to absorb the amount of information that he holds in his brain. But I have learned a ton in the last 4 years.
So hopefully Perry's got 50 more years in him.
I
Easily.
hope so.
I turned 65 last Saturday. So
All right. Congratulations. So Perry, how in the world do you get from high school to where you're at today?
well, I guess going back a little bit further than that, I got zapped with 115 volts when I was about 6 years old because I started taking things apart when I was a child. So I got electrocuted, and Father found me in the basement connected to the wire. But
Oh, wow.
anyway, so that explains a lot for everybody here. But
Yeah, that's where that switch came from.
I ended up starting to take things apart, and I, actually right out of high school, I went to become a electronic technician. So I graduated in 77, and 78, I went into electronic school to become a electronic technician. At the same time, I had a part-time job at a place called Parametrics in Orange, Connecticut. They were started in about 1975 making drives. So I went from pushing the broom on that floor to an engineering tech and manager of application engineering through that period of my life. And in 1986, ASEA bought Parametrics to get the U.S. market share for HVAC drives. And at that time, then ASEA merged with Brown Boveri in 1988 and became ABB as we know it today. So I've been doing drives my whole career, and ABB drives pretty much for my whole career, starting in 1978. That's a long time ago. So I've done nothing but drives, and I've had 3 jobs in my whole life, and they've all been with drives.
Okay.
So I like
Very
working
cool.
with the HVAC side of things because the people that I had to deal with from a consultant engineering standpoint were more interesting to me than the industrial side of the marketplace. So,
Very neat. So tell me, guys, so in our industry, you can have, across the line starters, you can have solid state starters, you can have Y delta starter. What's the difference? If we could just kind of walk through those real briefly about what the job of each of those does, and then how the VFD replaces those.
okay, well, across the line starter, you have 2 choices. You're either on or off, and you're on at full speed, 100% speed. So if it's a fan, you're blowing 100% airflow into a space. If it's across like a Y delta starter, you will start at one speed and change to another speed to help the inrush, reduce the inrush of current that it takes to start these devices. And all of those devices, across the line starter, soft start, and a Y delta starter, it only allows you to operate at one speed, one fixed speed, and that's the nameplate of the motor. What drives allows us to do, VFDs, it allows us to take a standard AC motor, like a totally enclosed fan-cooled motor, and we can drop the speed of it, saving energy. That's the whole reason we put drives in HVAC. Because in an HVAC system, it's usually designed for the worst case scenario, meaning the hottest day of the year or the coldest day of the year. And when we're spinning along at full speed trying to cool something, we may not need that. So what the building automation and the drive does is it drops the speed of the fans in the building, saving energy and making people aware that there still is airflow and making them feel happy and warm and fuzzy when it's the wintertime.
Yeah, so I came from kind of the heavy metal side, and one of the things that I always operated under and as an engineer when I worked for a consulting engineering firm was IPLV, which is intermittent part load value. And so what you find out is like a system usually is going to operate at 100%, 1% of the time. And then the rest of the time it's going to kind of flow between that 40, 20, 25 to 75 range is where that percentage really is a lot. And so to Perry's point, you're never really seeing systems operating or needing to operate at 100%. It's a lot of wasted energy.
Yes.
So Perry, Perry and Natalie, with that soft start, with that ramping of capability, does that help with saving the motor at all?
Well, yes, it actually helps the motor from a torsional standpoint and the fan or pump from a torsional standpoint, because it's not slammed on at full speed 100 instantaneously. We slowly ramp it up over a period of seconds to minutes. So it's an adjustable value. So there's no mechanical stress, and we never go above the nameplate current rating during the start process. If you start a motor across the line, usually it pulls 6 to 8 times the nameplate current value until the fan would get up to speed. So there's lots of less stress. We don't stretch belts. You don't hear them squealing, and less mechanical wear and tear on the system, in addition to the energy savings.
Mm-hmm. Kind of when someone was explaining to me a VFD many moons ago, if you think about a car, you can either not be on the gas pedal or hitting the gas pedal down all the way, whereas a VFD more so allows you to hit the kind of the speeds that you want to go whenever you're driving taking that drive.
Yeah, you can stop at any speed from 0 to nameplate RPM of a motor. So if we have an 1800 RPM motor, we can actually go up in 5 RPM increments from 0 to nameplate RPM and control it. Even actually better resolution than that. But we have all those points that we can stop at. So it meets, infinite levels of demand by the building automation system, because we constantly modulate up and down to meet demand. And I'm Italian, so I talk with my hands sometimes. So
gotcha. So tell me about how it seems like today when you're talking with engineers, it's almost like one of the things they want to do is go ahead and throw a VFD on the unit regardless, because if anything, it can act as a soft start for it and ramp to wherever it needs to be. And you can set it at the appropriate place. So it helps a lot with dialing in from to make sure that it's hitting the specifications for whatever that building is, external static pressure and whatnot. So
air balancing.
Air balancing. Thank you. So, so how in the world is it that we got from, the invention of that first VFD to where now it seems like it's so affordable? Because, I've been in this business for a little over 20 years now. When we first started, there was still an economic hurdle to get over to get to that VFD, and now it seems like that barrier is almost gone. Kind of walk me through the evolution of the drive.
Yeah, well, drives, back in the late 70s, early 80s, they were fairly large and fairly expensive, and so the technology of the changing technology of the power semiconductors or the transistors in the drive have actually enabled us to shrink things down and still generate the same amount of power in a much smaller package. So like in 1978, a 5 horsepower drive weighed 125 pounds. And now they're about 3.5 pounds. So that's a huge reduction in size. And that's just been strictly technology. And I hit the electronics school time in 1978. I was still doing transistors and vacuum tubes, and I went from that to microprocessors, and then microprocessors got put into drives, and they just exploded. And that started in the early 80s, and that's when we really started putting them on fans and pumps to save huge amounts of energy.
Harry, how many people would it take to install a drive that weighed 125 pounds? Would it take two of you, or could one of you do it? Just curious.
Well, I used to carry it back then into the
Ah.
burn-in room. I'd have to pick it up after it was tested and hang it in the burn-in room. Burn-in room was a 40 C test location at full load. That was how he tested all the drives. They still do that today. They run them up to full
Okay.
speed, full loads, and bake them for 15 minutes. So
Wow.
two people can do it a lot easier, but
But you could do it in one.
yeah, when I was 18, I could, not anymore.
So the kind of the next question I have for you is how, I haven't been with, with Hoffman, but for a little over almost 5 years now. But it seems like when I was previously at another manufacturer, and then when I was also at an engineering firm, ABB, the name itself was almost like the word Kleenex. Like you knew when it was ABB, you were talking about a variable frequency drive. How in the world did it? I don't want to say household name, but maybe something like that. So how in the world did it become that kind of that household name within our industry?
Well, like I said, ABB purchased a company that had been around in the U.S. for a while, a drive manufacturer, but they focused in the early 80s on selling HVAC drives and actually breaking out the part of the business where there was an industrial side and an HVAC side. So we focused on the HVAC side, and it enabled us to get to all the consultant engineers, get the products specified. We basically sell them, start them up, service them. So it's like cradle to grave responsibility with them. And ABB doing that nationwide, it was worldwide. They're a $39 billion multinational company. They employ about 35,000 people in the United States.
Wow.
Alone. But the way that the cradle to grave of the drive regionally, whoever sells it is responsible for it, gives you great service, great response time, and uptime, which is really important. So that's how it's gotten that name. And they've been around. They were kind of like the GE of Europe, if you're familiar with the GE here in the United States. They do everything from trains that tilt to power systems. They'll build power plants. The windmills, ABB does windmills, electric cars, the whole gambit. So they're very high tech. They put at least 20% of their profits back into R&D every year.
Wow.
So they definitely stay leading edge. Leading edge or bleeding edge technology, sometimes we call it, but hopefully it's just leading edge.
And to kind of piggyback off of that, on the non-equipment side, the way that ABB's rep program is set up is each office who sells ABB is required to have a dedicated, at least one or more than one individual. So we've got our AC drive specialist and then myself, who acts as a liaison between our customers or our salespeople and the factory. So your service and response time is going to be astronomically faster when you're going straight to your rep instead of having to wait and go to the factory or whoever it may be, or the rep from the manufacturer. So they've got it structured so that they have probably 5 times as many boots on the ground, whereas and I don't know, just speaking off possibility, if you're going with another manufacturer, the connection between the two, there's probably some discrepancies as far as going to service or tech support or whatever it may be. With us or with all of their channel partner programs, you've got dedicated individuals in each rep's office to service and support ABB drives. And so I think that really kind of puts them out there and helps them lead the way, aside from just their technological advances.
Almost, I think maybe another way to put it for people listening is almost like a white glove approach is what it kind of sounds like.
Yeah.
Yes, it is. And, here at Hoffman and Hoffman, and I know that the customer always comes first. So that's also what's been driven into everybody here in this work environment, to make sure that the customer is taken care of no matter what. That was Rusty Hoffman's main thrust when they hired me back 13 years ago. And that's, that's what we do. That's a company. So that's how we support the drives or anything we do.
Yeah, I would agree that very much, Rusty, put that ethos within our organization. To add to what you guys are saying, the mechanical side, which is the side that I'm on, the service arm of Hoffman, we actually have technicians that are dedicated just to variable frequency drives. And that's actually a pretty unusual thing to see, because you think that the jack of all trades can be the guy that also messes with the VFD, but there's actually a lot of intricacies involved with it to make sure that it's running properly and maintained. And we actually, a lot of people don't know this, but we actually have maintenance recommendations and service agreements just on variable frequency drives because of the need to keep up with them as well.
And ABB's drive itself has a 3-year on-site parts and labor warranty right out of the box for everybody. That's something else that some of the competitors don't do. Some of the brand D and brand S and brand Y, they don't have that on-site parts and labor warranty, which means if it's a hospital operating room, you can't have that down. That's huge amounts of money you're wasting if you're not filling that space. So with the service, the group, and the parts, we have local drives in stock, and the people that, like I said, we service them, install them, and get them back and running again. So that's really what made the market share grow. And ABB is about 48% market share in the HVAC industry. So that's where that Kleenex name type of thing has come from.
Gotcha. Very cool. So Natalie, if I could put you on the spot. So tell me about this name Freq Squad that you guys have. And then also, if you could, tell me a little bit about maybe a situation where you just helped satisfy a client. Like there was just a situation and y'all kind of figured out a solution to that.
So the Freq Squad came about, what do you think, 2 years, a year and a half ago, maybe 2 years?
Yeah.
What is it, 2024? So like right post the heat of the pandemic, dare I speak that word.
Yeah.
But as our companies were growing, we recognized the need to kind of improve the way that we support all 4 companies internally and externally. And so we came up with the idea to create a group, and essentially what the idea started from was a group of superheroes, champions, people you can call on when you're in a crisis. Like, don't worry, we're here to save the day. Because believe it or not, a majority of the calls and emails that we get are kind of situations like that, like, help me, I'm down and out, or I need to retrofit and replace this drive, and I have no idea what this is. This thing is from 1996. And so that's where the Freq Squad came about. It's myself and then our drive specialists, and we serve all 4 companies within the Hoffman family. And then our goal is to kind of put the word out more externally so that people can just email straight into the Freq Squad and get an answer as quickly as we possibly can, and not have to call 5 different phone numbers and hear from somebody who has no idea who they are. I could give you plenty of scenarios where we've helped some people who are down and out, but during COVID, lead times, which I'm sure across the board were astronomical for everyone else, but we kind of felt like we were on fire and running from the opposite direction of water with ABB drives. And there were multiple scenarios where hospitals or data centers or you name it are like, I need this drive yesterday. I have this, whatever it may be, out. And we have a network of other channel partners who also rep ABB. And we were able to communicate with them during the time that the lead times were pushing into weeks and weeks and weeks, and try to source drives from them and vice versa. And so we kind of probably saved ourselves and helped our company displace competitor opportunity many a times by relying on other reps within the United States to source drives for people that were down and out. And we probably would have had to go back and kind of play recon and replace them with ABB anyways, but being able to continue to lead in the industry during a time where nobody, well, I don't want to say nobody, but access to certain things like ABB drives were scarce, definitely was rewarding and helped us secure relationships going forward for sure.
Very
That's
cool.
amazing.
Another thing we did too, application experience. That's what I've got a lot of because I've been around for a lot of years. And some things that gets missed a lot of times in retrofits in a building is the minimum speed settings that we put on drives for pumps and fans and so forth. And I was working with a project company in Raleigh that had hundreds of drives over many of years that had been installed. And you ask somebody what the minimum speed is, and they'd say 20 hertz or 25 hertz or 30% speed. Anyway, I went back to this customer and said, contact all of your air handling manufacturers and find out what the fan surge points are for those air handlers. And they did, and went back, and we were able to drop the minimum speed from 20 hertz down to like 6 hertz.
Wow.
Basically, what that did was save that customer $50,000 a month in energy savings.
Wow.
So there's
Wow.
huge amount of savings, and that's just little application details, subtleties that we understand. The right enclosure for the right environment. A drive is a pretty sophisticated piece of equipment. If you wouldn't hang your flat screen TV on a wall where you're thinking about putting the drive, don't put the drive there. We'd have to put a special enclosure around it to protect it. So we got a lot of that experience, and that's how we help people. And, so the Freq Squad is there for any questions, anybody's drive. Obviously, we want to lead with ABB as a solution, but we'll answer questions about anything.
So my last question for you guys. So what is the biggest VFD you've ever seen, and what is the smallest?
Smallest has been fractional horsepower, and the world's largest drive is at NASA Langley, Virginia, and it's 125,000 horsepower.
Wow.
It's the size of a 40 by 40 by 40 room. You actually walk through this thing and buy the semiconductors. And it's on a wind tunnel project at NASA Langley. So that's the largest drive I've ever been around. I think it sold for $6.8 million, but
wow, very cool.
Wow. I can't say the same. I have not been around a drive that massive. Although, if you've met Jimmy Johnson, our other drive specialist, he's very tall. The largest drive I've ever seen was taller than him, and probably, I can't even say how wide. It looked like, I don't even know what to compare it to. It was huge. And I was intimidated because I was not prepared. I'd looked at the drawings. I'd seen the thing. I saw pictures of it. But in real life, when he's standing next to it and he looks short, I was like, okay, this is overwhelming.
Yeah, he's like 6'5", maybe. I don't know.
Something.
He's really tall. Yeah.
Yeah.
Wow.
That's
They were
cool.
humongous.
That's when he has his lift on, so I don't know.
His lift.
But
he's not here to defend himself.
We've done quite a lot of large, high horsepower drives. We do a lot of chiller plant work now for data centers to keep things cool. And there's lots of 300 and 400 and 500 horsepower pump motors, primary chill water pump motors. And we've been doing more and more of that. We do lots with data centers. So we get involved in all this high horsepower stuff. And, 500 horsepower drive is pretty good size for commercial HVAC.
Oh, yeah.
So
it's a lot of horses.
Yeah. A lot of horses running
lot of
fast
horses.
or slow, depending on what you need them to do.
Exactly.
Well, very good. Well, thank you, Natalie and Perry, for your time. Kelly, what was your big takeaway, if I can put you on the spot, from what Perry and Natalie told us today?
Honestly, my big takeaway was the fact that drives used to be start and stop, right? And now we can adjust speeds according to what the system needs, right? And from what I'm understanding, the system tells the drive what speed it needs the drive to go at. Is that right?
Yeah, the building automation system.
You explained it even to me, Perry. It's pretty impressive. Pretty
I,
impressive.
I think my big takeaway is one, the saving of the motor because of the soft start application that you naturally get with the VFD. And I think the other one is that the savings that you can have when you start paying attention to motors and being able to run them at a lower frequency. So a lot of good takeaways from this. Thank you guys so much for your time. And
Well,
Kelly,
thanks for asking.
yeah, absolutely. Yeah. Kelly, you have to make sure you remind me that we have to say at the beginning of all of these that you have to, if you enjoy it, to like and subscribe.
Oh my gosh, yes. We need to do that at the beginning.
Yeah, those are things that a lot
Yeah.
of other podcasts have down pat. We do not. And
We're
so
not
this is
yet,
our,
but this is just number 3.
Mhm.
Just number 3. We're still newbies, Ryan. It's fine.
Okay, so after today, we're going to be, Perry, Natalie, you guys don't know this, but 90% of podcasts don't make it past episode 3. So you guys are helping us to get into the minority.
Oh boy.
Of
What if we're the
podcasts.
opposite? What if we're detrimental to you getting past the 90%?
Oh no.
Mm.
Oh no.
Yeah.
This was
Natalie,
a good one.
Works
my
both
cup
ways.
is half full.
Right?
Half full. Optimism.
We're
always.
optimists. We're optimists.
Good stuff. Well, thank y'all again. And once
Thank
again,
you,
this
guys.
is HVAC-OLOGY.
Yay.
Take care.
Thanks, guys.
Drove an hour to see you. Things just seem to matter more to me anyway. Got lost in reality, no answers to cancer. We never got to talk. Lost so many friends as I got older. Wish I had the strength to hold you a little bit longer. Always meant to write these words down. Thought all the best of you, faded in the sea. But you always bring me back at your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back the words inside of me. Always bring me back at your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought